Hi, another video. This one will be quite a long one. So it says a model for a rocket of mass m is being launched with initial velocity u meters per second can be expressed by this differential equation: m dv by dt is equal to minus mg minus kv, where g is acceleration due to gravity, v meters per second is the velocity after t seconds, k is a positive constant. Solve the differential equation to show that the velocity will be this: 1k times mg plus ku e to the minus ktm minus mg. Hence, find expressions for the displacement s and acceleration a, given that when t is 0, s is equal to 0. And find expressions for the limiting value of the velocity of this model. Now, before we start, there is a GeoGebra app for this, and you can get it from the link of the video. So just have a quick look at it. Here it is, the velocity equation, and if we click on these things, so it's got a given mass of 5 and k is 10 at this moment and u is 75 meters per second. That would be the displacement equation. This would be the acceleration, and then if we see here that we have a limiting value of minus mg over k. If I just remove the acceleration there, you get that. Okay, so you can get these equations, all these equations. We're about to now derive this one and this one and this one. Okay, I hope you enjoy this video. So let's go back to the maths of this then. Okay, so if we start with the differential equation, okay, it's just this little trick here is to take out the minus sign. So you get m dv by dt minus mg, but remember designing this changes to a plus kv, and then we will put a minus 1 in here, and then we will separate the variables. So we'll take this down here. So we're going to get m over mg plus kv, dv by dt is equal to minus 1, integrating both sides with respect to t. So if we do that, we're going to get the integral of this times dv by dt is equal to the integral minus 1 dt. So actually this side we're integrating with respect to v. Now this is an ln, so if we try ln of mg plus kv, remember that m and g are constants and k is a constant, then we're going to get, when we differentiate this, we're going to get k over this. So we're going to have to, and m from the m here. And so therefore we're going to have to compensate by putting an m over k. If you're not sure about this bit, pause the video and practice just differentiating this bit for yourself. And you'll see that you'll have to put that in. Now if we integrate minus 1, we're just going to get minus t plus c. Okay, so when t is equal to 0 seconds, and then v will be equal to u meters per second, and therefore we're going to have 0 plus c. 0 plus c is going to be equal to this side, mv ln of mg, but this will be ku. So c will be equal to mk ln of mg plus ku. So we'll need to put that c in here. So putting that into the velocity, the equation that we've got here for velocity, as adding in the constant here, and using log to the base a of x over y, and we're going to use this one. So what we're going to do, we're going to take this over here, take out the common factor of m over k, then we've got a log minus a log, so we can write it as log x over y. So we're going to have m over k, ln of this one, divided by this one, and that's going to be equal to minus t. So remember now that making the object is to make this variable here v the subject. So it's not as difficult as you think. First of all, multiply by k over m. So we're going to get minus k over mt. And then we're going to lose another rule of logarithms. Log to the base a of b is equal to c implies that b is a to the c. So we're going to have mg plus kv over mg ku is equal e to the minus kt over m. We'll take this up here. So we're going to have the mg plus kv is equal to mg plus ku e to the minus kt. Just write it over m, and then writing that out again. We're going to have that kv is going to be mg plus ku e to the minus kot over m minus mg, and then dividing by k, so just putting 1 over k and putting square brackets in of mg minus ku e to the minus km minus mg as required, as given in the question. Right, for part B, the displacement is the integral of this, so we'll integrate this. So we'll just take out the 1 over k. Now, so we're doing the integral of all of this. So integrating that, we're going to get 1 over k. We're going to have mg plus ku, because these are all constants. Now, when we differentiate this back, we're going to have a k minus k over m. So we're going to have to put in here a minus m over k, e to the minus k over m. And then if we integrate minus mg, we're going to get minus mgt. But we're also going to get another constant integration, which I've called c subscript s. Right, so having done this, we now need to find what this is going to be. And if you're not sure about this bit, pause the video and just check it for yourself. Okay, so when t is 0, s is 0. So we're going to have that 0 is equal to 1 over k, mg ku, m minus m over k, e to the minus k times 0m, minus mg 0 plus c. That's good, because this bit here will be equal to 0. But minus km times 0 will be 0. So e to the 0 is actually equal to 1. So all we're going to get left bit is this bit here. So we're going to have that 0 is equal to minus mg ku, and then k times k will give me k squared, plus our constant. Therefore, our constant will be the positive part of this, m times mg plus ku over k squared. So putting it all together, s will be equal to 1 over mg ku minus mok e to the minus kt over m minus mgt plus our constant. Okay, notice this will be k, because if you you have this 1 over k originally was not in the bracket, so this will be all this over k. So in order to put it within the bracket, we have to put a k outside, and that will just become k. Okay, so carrying on. So if we use v is equal to our equation that we've already just derived. Okay, to find a, we just need to differentiate this. So that will be dv by dt. So it'll be 1 over k. This is a constant. And then from here, we're going to get an extra minus k over m. So mg plus ku times a minus k over m from here, e to the minus kt over m. This bit, if you differentiate constant, you get 0. So that will be the acceleration. Now, looking at this equation here, for part C, when t goes to infinity, okay, so we'll need to have a look at this bit here, what happens to this bit here. So the big interesting thing is e to the minus kt over m, which is equal to 1 over e to the kt. So this will become 1 over a very, very large number, which is like 0. So this will be 0, and we'll be left with minus mg over k. So the velocity, the limiting value of the velocity will be minus mg over k. So if we go back to the GeoGebra app again at the end, okay, so if we click here, we can see the displacement equation that we just derived. Okay, we can see the acceleration, and if we click here, we can see the limiting value of the velocity. The link of this GeoGebra app I will put in the notes of the video. I'm sorry it's quite a long video, but I hope you've enjoyed it. And if you want to, I'd ask you to consider subscribing to my channel. And thank you very much for watching.